this video, we are going to discuss the geometric view of variance and standard deviation. Variance and standard deviation are measures that indicate how much the values of the set of data deviate or spread out from the mean. They show whether your data is close to the mean or fluctuates a lot.
Good day, I am Michelle Sombrero Tabornal, and now I am going to discuss the population variance.
Population variance formula is a measure by the average distances of population data, and it is calculated by finding out the mean of population formula, and variance is calculated by sum of the square of variables minus mean, which is divided by a number of observations in population.
Example number 1, population variance. This is the number given. By computing population variance, this is the formula. Sigma squared equals summation of x minus x bar squared divided by the size of all numbers. And by computing population mean formula, this is the formula. Mu equals summation of x divided by the size of all numbers, or x bar equals summation of x divided by the size of all numbers. So, this is the number given. 62 plus 63 plus 65 plus 64 plus 68 plus 68 plus 69 plus 72 plus 66 equals 661. 661 divided by 10, the answer is 66.1. So, the mean population is 66.1. In this table, we compute the x minus x bar. By computing this, we need to subtract x and x bar. So, 62 subtract by 66.1, the answer is negative 4.1. 63 subtract by 66.1, the answer is negative 3.1. 65 subtract by 66.1, the answer is negative 1.1. 64 subtract by 66.1, the answer is negative 2.1. 64 subtract by 66.1, the answer is negative 2.1. 68 subtract by 66.1, the answer is negative 1.9. 68 subtract by 66.1, the answer is negative 1.9. 69 subtract by 66.1, the answer is positive 2.9. 72 subtract by 66.1, the answer is positive 5.9. 66 subtract 66.1 equals negative 0.1. So, this is the answer. By finding x minus x bar squared, we need to find the square root of x minus x bar. So, the square root of negative 4.1 is 16.81. The square root of negative 3.1 is 9.61. The square root of negative 1.1 equals positive 1.21. The square root of negative 2.1 equals positive 4.41. The square root of negative 2.1 equals positive 4.41. The square root of negative 1.9 equals positive 3.61. Negative 1.9, the square root is 3.61. The square root of 2.9 equals positive 8.41. The square root of 5.9 is positive 34.81. The square root of negative 0.1 is positive 0.01. So, this is the answer. Summation of x minus x bar squared equals 86.9. So, this is the Answer 86.9. So, by finding the population variance, this is the formula. Sigma squared equals summation of x minus x bar squared divided by the size of all numbers. So, 86.9 divided by 10 is equals to 8.69. So, this is the population variance.
To get the standard deviation, we are going to square root the variance.
Sigma equals summation of x minus x bar squared divided by the size of all numbers. So, we need to find the square root of 8.69. So, the square root of 8.69 is 2.95.
So the standard deviation of population is 2.95.
Hello, this is Ira J. Cadiz.
And I am going to discuss sample variance. These are the steps to calculate sample variance. First, find the mean of the dataset. Add all the data values and divide by the sample size n. Second, find the square difference from the mean for each data value. Subtract the mean from each data value and square the result. Third, find the sum of all squared differences. And last, calculate the variance.
And now, I will going to give an example. 5 random people are selected from the mall to understand the demographics of its customers. The given are 10, 15, 14, 12, and 18. Determine the variance and standard deviation. First, calculate the mean. So, by calculating the mean, this is the formula. X bar equals summation divided by the size of all numbers. So this is the number given. 10 plus 15 plus 14 plus 12 plus 18 divided by 5 is equals to 13.8. So this is the mean. Second, sample variance. By computing variance, this is the formula. Sample variance equals summation of x minus x bar squared divided by the size of all numbers minus 1. In calculating the variance, we may use the table to write those set of data and accurate. So this is the table. The x and x bar is given. So by finding x minus x bar, we need to subtract these two. 10 subtract by 13.8 is equals to 3.8. 15 subtract by 13.8, the answer is 1.2. 14 subtract by 13.8, the answer is 0.2. 12 subtract by 13.8, the answer is negative 1.8. 18 subtract by 13.8, the answer is 4.2. So this is the x minus x bar answer. So by finding x minus x bar squared, we need to find the squared of these numbers. The squared of negative 3.8 is 14.44. The squared of 1.2 is 1.44. The squared of 0.2 is 0.04. The squared of negative 1.8 is 3.24. The squared of 4.2 is 17.64. So, summation of x minus x bar squared, the answer is 36.8. And this is the example or the computation of sample variance deviation. 10 minus 13.8 squared plus 15 minus 13.8 squared plus 14 minus 13.8 squared plus 12 minus 13.8 squared plus 18 minus 13.8 squared divided by 5 minus 1. And so this is the answer. 14.44 plus 1.44 plus 0.04 plus 3.24 plus 17.64 equals 36.8. 36.8 divided by 4, the answer is 9.2. So, this is the sample variance deviation 9.2. By finding standard deviation for sample data, this is the formula. S equals summation of x minus x bar squared divided by the size of all numbers minus 1. We need to identify the square root of 9.2. So, the square root of 9.2 is 3.0335. So, this is the standard deviation of sample data.
Math Buhay! I am Teacher Raquel, and there's nothing too big or too small because we will learn it all. So get motivated and stay with me because we are together in this wonderful journey. I will be discussing variance and standard deviation of ungroup data. If we let s squared be the variance, then we have variance is equals to summation of x minus x bar quantity of 2 over n, where x represents the individual values in the distribution, x bar is the mean of the distribution, and n is the sample size. In calculating the variance for ungroup data, we shall consider these following steps. First, compute the value of the mean. Second, get the deviation of each value from the mean. Third, square the deviations. And fourth, calculate the sum of the square deviations. And lastly, divide the sum by the total number of values. And now, we are going to apply those steps that we shall consider in calculating the variance for ungrouped data. Example, compute the value of the variance of the following measurements: 13, 5, 7, 9, 10, 17, 15, and 12. For simplicity, we shall first arrange these values in magnitude in a vertical column. Using the steps indicated above, we have. So as you can see, I wrote all the values of x or the individual values in the distribution in a vertical column, which are 5, 7, 9, 10, 12, 13, 15, and 17. So first step is to compute the value of the mean. Using this formula, x bar is equals to summation of x over n, where x bar is the mean of the distribution, x represents the individual values in the distribution, and n is the sample size. To find the summation of x, we should add all the values of x, which are 5, 7, 9, 10, 12, 13, 15, and 17. So we have 88. To find the n or the sample size, we will count all the values of x, which is the individual values in the distribution. 1, 2, 3, 4, 5, 6, 7, 8. So our sample size is 8. Mean is equals to summation of x, which is 88 over n, which is 8. So 88 divided by 8 is 11. Step 2. Get the deviation of each value from the mean. Since our mean is 11, I put 11 in each x values in a vertical column. Given the formula x minus x bar, so we have to subtract the mean from the x values. 5 minus 11 is equals to negative 6. 7 minus 11 is equals to negative 4. 9 minus 11 is equals to negative 2. 10 minus 11 is equals to negative 1. 12 minus 11 is equals to positive 1. 13 minus 11 is equals to 2. 15 minus 11 is equals to 4. 17 minus 11 is equals to 6. Now, we are done getting the deviation of each value from the mean. Next step is to square the deviations. Given this formula, x minus x bar squared. So all we have to do is to square the data in column 3. The square root of negative 6 is 36. The square root of negative 4 is 16. The square root of negative 2 is 4. The square root of negative 1 is 1. The square root of positive 1 is 1. The square root of 2 is 4. The square root of 4 is 16. And the square root of 6 is 36. In step 4, we are just going to add or sum up the data in column 4, which is the square deviation. So 36 plus 16 plus 4 plus 1 plus 1 plus 4 plus 16 plus 36 is equals to 114. Or summation of x minus x bar squared is equals to 114. Next, divide it by the total number of values. Using this formula, variance is equals to summation of x minus x bar squared over n. So the summation of x minus x bar squared is equals to 114 over n, which is a sample size, is equals to 8. So 114 divided by 8 is equals to 14.25. To calculate the standard deviation, we are just going to square root the variance. Using this formula, variance is equals to square root of summation of x minus x bar squared over n. Since summation of x minus x bar squared over n is equals to 14.25, let us just square root 14.25, which results in 3.85.
Good day everyone. So in this video lesson, we are going to discuss the measure of relative position, especially z-score. Z-score. A z-score measures the distance between an observation and the mean measured in unit of standard deviation. So we are going to use this formula. Value minus the mean over standard deviation. For population data, we're going to use this formula. So this is the formula. X minus the mean. So we are going to use the symbol over the standard deviation. And for example data, we are using this formula. So x minus the mean over the standard deviation. Remember, if the z-score is positive, the positive score is above the mean. If the z-score is 0, the score is the same as the mean. If the z-score is negative, the score is below the mean. Again, if the z-score is positive, the meaning is the score is above the mean. If the z-score is 0, the score is the same as the mean. If the z-score is negative, the score is below the mean. For example, an IQ test has a mean for 105 and a standard deviation of 20. Find the corresponding z-score for each IQ. So first is the score is 80. So using this formula, value minus the mean over standard deviation. So substitute lang natin. So that is 88 minus 105. So the value of mean is 105 over 20, or 88 minus 105 divided by 20. The answer is negative 0.85. Since the value of our z-score is negative, So therefore, is 88 is below the mean. Next, 122. Okay, our score is 122, same process. Using the formula, we substitute 122 minus 105 divided by 20. The answer is 0.85. And 0.85 is positive. Therefore, 122 is above the mean. So next is 110. Using the formula, we are going to substitute 110 minus 105 divided by 20. That is 0.25. 0.25 is positive number, so the meaning our z-score is positive. Therefore, 110 is above the mean.
Which of the following exam grades has a better relative position? We need to find out the z-score of the two tests. Okay, for the first test, in algebra test, with a grade of 43, okay, let's find out the value of z-score. Okay, this is for algebra test. 43 minus, this is for the algebra test, 43 minus 40 divided by 3, and the z-score is 1. Okay, let's proceed to the geometry test. For the geometry test with a score of 75, okay? Okay, 75 minus 72. Okay, this is for the geometry test. With a grade of 75, 75 minus 72 divided by 5, and the z-score is 0.6. Okay, the z-score for the algebra test with a grade of 43 is 1, and for the geometry test with a grade of 75 is 0.6. Okay, so since the z-score for the algebra test is larger, so the position in the algebra test is higher than the position in the geometry test.